Very good evening, everybody. Welcome back. Apologies for my absence yesterday. I was not perfectly well. I decided to take a little bit of rest, and I knew that anyway, the heavyweights are there to take care of it. So, yeah, once in a while, in the round robin fashion, sometimes one of us may not be there. That is expected when we are having this event for such a long time. But the show will go on as always. So, yeah. So thank you, everybody. It's been an amazing, we're going to be very soon hitting the 30 days mark. All right. So it's been so many days that people have regularly been coming, and it is really heartening to note that we are getting a lot of traction, and a lot of people are calling us, letting us know that this is an amazing thing. It is helping them out. Some people, couple of them have already had some success with reference to jobs. This also helped. We cannot say that this alone helped. Multiple things, but everything, join hands together to have that success. So you cannot rely on just one source. So yeah, that's for that. It's we trainers, we data scientists from 360DigiTMG, we live for that. Those kind of little bits of happiness and news, we live for that. So that's on that positive note. Let's begin. Barney is held up in a meeting. He'll be joining in a couple of minutes. In the meanwhile, let's start. So the topic for today is decision tree and hyperparameters, modeling using decision tree and hyperparameters. We have done some brief study about decision tree and how, in fact, we had a war of words, myself and Sharath especially, about why decision tree is, the most, what shall I say? Excuse me. Not recognized, or the really strong one, but doesn't get its due, what it should get among the various models. Everybody runs towards neural networks and things like that, and they say, "Yay, neural networks is great." But the decision tree also is a real hard worker, a workhorse, but doesn't get the due credit what it should do. So we'll try to give it some credit. So Sharath, could you just start off by telling me about the generic interview question could be like, why is decision tree chosen as a modeling? On what basis do you choose decision tree? Could you just throw some light on that?
Yes, Nitin. Good evening. Good evening, everyone. And again, as usual, welcome back to the channel, and very happy to see you all. Hope you're taking the advantage, right? So that is more important, and hope you are noting down all the discussion points that we are having here. Coming to the topic, decision tree is one of the very, very fancy algorithm, I would say, because of all the noise it makes for good reasons or bad reasons. And like Nitin said, the decision tree does not get the due weightage that it should receive. But it becomes one of those very important base ingredients which actually forms or allows us to form very complex algorithms. But of course, it's a vanilla model, the basic model, and it runs on rules. And because of these rules, decision tree becomes one of those very, very important algorithms which can be used for explainable scenarios. And decision trees are heavily used in sectors like banking, where there is very, very high importance given to the explanation of your results. So decision tree gives us classification rules, the path, the sequence steps. And thanks to this information, we will be able to interpret the results. But the decision tree also has the problem. Because of this specific problem, it does not get its due diligence, due importance. And that problem is overfitting problem. Among all the algorithms that we talk about in predictive analytics models, decision tree is the model which is most prone to overfit. the algorithm is designed in such a way that it generates rules on all the records of your training data set. So it tries to force fit each and every record from your training data. And when that happens, when you're trying to fit in, or when you're trying to predict the results on the same training data set, you would get appropriate result thanks to the force fit design of the algorithm. So you're going to get 100% accuracy on your training data set. But when you use those rules to try and predict on your test data set or validation data set, you may not get the exact result that you seek. So it fails to give you the right predictions on test data set or validation data set. And this is where you see overfitting problem. Now, when do you choose? I've already mentioned, wherever you need to have the explanation done for your models, we always rely on these explainable models, and most preferred is decision tree. And the another advantage that decision tree also gives us is the list of hyperparameters that it contains. Whenever you want to tune your algorithm, whenever you want to fine tune it and improve the performance, every algorithm has a bunch of parameters, which everybody knows here, right? So you all know about it. But decision tree is one of those algorithms which has a huge list of parameters, right? So that is the reason why the decision trees are also preferred. But again, the drawback is still there. Hence, it doesn't get its due importance.
Thank you, Sharath. I appreciate the detailed explanation that you've given towards the choice of decision tree. All right. Now, for a novice, for a person who's given a business scenario, and or for instance, let us put it in the perspective of an interview question itself. You are given a business scenario. You have this data. You have data which is having a mixture of categorical and continuous values. The output is discrete. The output is discrete in multiple categories. I propose to use decision tree, and I propose to use some other classification algorithm. Let us say a k-nearest neighbor classification algorithm. Given this much information, which do you think would be better? Which model would give me better results? How would you answer such a question? I'm not getting into the details of the variables and all that, but yeah, you can probably assume something. And the point I'm trying to make here is that the knowledge of or the requirement of explainability has not been mentioned. So how can we take this to the next level?
All right. So one specific point that you mentioned, which caught my attention, is you have mixed input factors, mixed data. And this is something that captured my attention.
Yes.
Now, when we try to predict the target variable, which is you're saying is a discrete value.
Multi-class. Let me correct you. Multi-class, not binary, but multi-class. Yeah.
Done. So discrete, but it is discrete, right? So multi-class. Yeah. Now, when you have this kind of a scenario, to be frank, we don't have predefined rules to say that you have to use decision tree, or you have to use K-NN, or you have to use night-based algorithm. We generally try and apply each of these algorithms and see which one is behaving better. Now, when we try to apply decision tree, because we are focusing on our this particular session on decision trees, I'll throw more light on that. I'll be focusing on that. When I want to use decision tree, one of the important prerequisite point that you need to remember is that your input factors that you're using should always be discrete in nature. They cannot be continuous in nature. Because the decision tree is trying to split your data, right? Divide and conquer manner. It is trying to split the data to generate homogeneous branches. Now, when you are trying to create branches, we basically take an input factor, and based on this particular factor, we create the branches on the conditions that the input factor has. But can I have an infinite branches? I cannot have infinite number of branches. Hence, the requirement is that your input factor should be discrete. If you have continuous data, obviously you will have to do those manipulations. For every algorithm, you'll have certain conditions. In decision tree, we need to ensure that we discretize the data. So if you have a continuous data, you try to break that up into groups and use that as your input. So that is one of the points that we use. I mean, that's the way decision tree is applied. And once you get the results, you will try to see the rules that are getting generated. The Python libraries will allow us to also visualize the entire tree and then see what is the flow of the data and how a rule is created. And in decision tree, we generally say the path, the flow from the first node, we call this as root node, till the leaf node. So it's like your flow chart where we are trying to follow the flow based on the conditions and reach the last node. And when you see the last node, you should be able to define the categories belonging to that particular node. You should be able to define, right? So saying that this branch belongs to this category. So if you can do that, then this is our branch, or this is our rule. This path is our rule. And this allows us to explain our output. So this is the interpretability that we will be preferring with respect to decision trees over the other algorithms that we see.
Yep. Thank you. Thank you so much, Sharat. So we have Barney, who's joined just now. Welcome, Barney. So
Thank you.
We started without you because, like they say, show must go on. Thanks for joining. My question is to you, Barney. Like when we were discussing about the Bayesian algorithm, and then we discussed about how there is a problem of the zero probability. And that is probably the biggest problem that one faces when we have the Bayesian algorithm, and we have something to address that. So on similar lines, could you tell me what is the drawbacks or places where the decision tree fails? Any such scenarios are there where decision tree is not very good or is not preferred?
Yeah, sure, Nitin. Absolutely. So I would like to share my screen before we proceed further. I wish to show something pertaining to decision tree. And then I'm going to answer that question, if you may allow me. Okay. So I'm trying to open the specific post. And here we go. Yeah. So let me share my screen. So this particular post has garnered 17,269 impressions. And a lot of people were extremely happy about this particular post. And very clearly, you see that we have a flow from data ingestion until deployment, and post-deployment, what happens? Okay, given this context, to answer the question which Nitin has asked, yes, certainly, every algorithm has its pros and cons. And one of the disadvantages here is that, when you use decision trees, and if there is slight change in the training data, the entire rule changes. Okay, the entire decision rule which gets generated changes. To counter that, obviously, we have ensemble techniques, but then that's one of the disadvantages of decision tree. Another disadvantage is that if you have a huge number of numerical variables to deal with, then decision tree would be slower because it has to decide upon how to convert that into a categorical variable. And to create a categorical variable, it will just choose the midpoint, median, and then it will split. Nevertheless, when you have a numeric variable, there'll be a lot of rules which it has to figure out with respect to the best split. Yep. So these are a couple of disadvantages which we have when it comes to decision tree. Yep. Over to you, Nitin.
Thank you, Bernie. Yeah, thank you for also sharing that post, which is in a small way going viral, at least for 360DigiTMG. And I would request the audience here on YouTube to also have a look-see at that and spread the word about it. So that is on the side note there. So coming back to the topic of decision tree, Sharath, question to you. You mentioned in one of your explanations that there are huge number of hyperparameters with which we can tune the decision tree and get some good results. So restricting our discussion only to decision tree, what is the most popular and the strongest hyperparameter in your opinion, and why? Sharath, we are not able to hear you.
Sorry.
Sharath was checking whether you were active or not, Nitin. I mean, sometimes the interviewer also checks, right? Whether the interviewer is active or not. He frequently does that.
So the interviewee is checking the interviewer, huh? That's nice. That's the first time. Yeah. Yes, go ahead, Sharath. Thank you.
Yeah, I was just saying that I'll share my screen, and this is the screen, the cheat sheet. These cheat sheets are available on 360DigiTMG website. Please use that. Download the cheat sheet.
Where are those available, Sharath? If I may view that.
Let me navigate you to that. Let me show you. So I will go to the website, 360DigiTMG website, and under the learning resources, we'll come down, and this is the section where you see the cheat sheets. You'll be able to download that. When you click on this, it will ask for your basic details, name, number, and email. You can give those details. And once you give, the file gets downloaded into your system. And you will be able to see this file, the zip file, and you have all the libraries in compressed form. So I'm showing the decision tree.pdf file for you. This is the file. You'll be able to access the same file. Please download from the website, as I have shown you the process, and keep this file very, very handy. It helps you to remember the hyperparameters. Now, coming to the question that Nitin have asked, we have decision tree classifier. This is one of the algorithm under sklearn tree algorithm package. We will have decision tree regressor, we have decision tree classifier, and many other variants of that. And if I increase the font size, this is the syntax with which we can try and develop our decision tree model. And you can see these are all the bunch of parameters that we can pass through. And like Nitin was asking, what is the most important parameter? Now, all of these play a very, very important role in decision tree to define the performance of the model. But the most important thing is the criterion that we use for defining your branches. When you're trying to grow the decision tree, it will basically allow us to measure the criterion to split, on what basis you are trying to split your data, right, from your branches perspective. So to do that, we use criterion, and criterion by default is Gini index, which is one of the measure which allows us to capture the homogeneity parameter, homogeneity aspect in the data. But we also have Gini index along with that entropy and log loss. This becomes very, very important parameter for me, at least for me, that I would think that this is important. And as I mentioned, it is the function which allows us to measure the quality of the split. And on top of that, along with this criterion, we also have the various other aspects, like you'll see max depth. So how many branches you want to create, what level of branches you want to create. You might want to restrict your growth of the tree with respect to these parameters. You can refine the growth of your tree. We can also do pruning, that is nothing but your controlling of the growth of the tree. Minimum sample split. So how many samples should be there in my branch to further split it? Minimum samples leave. So after splitting, how many records should be there in my result, in the final branch? So on and so forth. There are many such parameters that we have. But as I mentioned, the most important one is the criterion. And without this, there is no value to the branches that you are splitting, and you may not get appropriate growth of the tree. We need the best growth. It is also called as greedy algorithm. Decision tree is also known as greedy algorithm. So we are saying that try to have a hybrid plant which can give you a lot of fruits rather than having a very big tree which probably has too many branches, and there at the end of some branch you will have a fruit. Given this opportunity, for example, the mango trees, obviously you want a hybrid tree which can give you a lot of fruits, because it takes less time to the growth of the tree and you'll be able to get better results out of that. So you will become greedy for the information with respect to decision tree algorithm. And that can be happening with respect to the criterion that we are choosing. So for me, criterion. Yeah, Nathan.
Sorry, I moved to a different frame. I was just looking at that LinkedIn link that Barney had shared. Sorry about that. Thank you, Sharath. So you claim that the criterion is the most important hyperparameter that one needs to choose before for a decision tree. And again, like I said, we are restricting our discussion only to decision tree. For all its shortcomings within the decision tree, what are the things that we can do is what you're trying to discuss. So Barney, over to you. My question is specific again to decision tree. So what are the hyperparameters that you feel, or not you feel, what are the hyperparameters that are probably least preferred, or something that is not much of use in the decision tree? They exist in the decision tree in the sklearn, but are more useful when we go for ensemble techniques. Any such parameters are there? Would you like to explain about that? Are you expecting me to remind you that your mic is muted, Barney? You're testing me, or it is accident?
But this time, for a change, it is accident, Nitin.
two sequential tests is not.
But you passed both successfully. That's the best part. Okay. So yeah, I shared with you that this link, which can be shared on our YouTube channel, on the chat window.
Yeah, I'll do that.
Having said that, while there are plethora of regularization techniques or hyperparameters which people can experiment with, and a lot of interviewers ask a hell lot of questions pertaining to hyperparameters from decision trees and ensemble techniques, because there are a lot of options available. And I would say not the least preferred, but the most obvious hyperparameter is number of estimators. That's number of trees that you want to run when it comes to ensemble techniques. And when it comes to decision trees, it's the maximum depth. Basically, I would say it's the most obvious. I would not say it's the most unimportant. For that case, none of the hyperparameters are unimportant. But I would say that if someone doesn't have time to experiment with different hyperparameters, then let your model run using the default hyperparameters. And the default options for each and every hyperparameter are defined just to ensure that your model gives the best results or somewhat good results in comparison to not experimenting at all. Yep, so I don't think there is any hyperparameter which is least important. Oh, yeah. And in almost all the algorithms, we'll have number of jobs, which is usually applicable when you have your GPUs and when you have more than one cores on your computers or servers. Usually on servers, you have more than one core, like dual core, octa core, quad core, so on and so forth. But on the personal computers, we most often than not do not have multiple cores. In those kind of scenarios, number of jobs becomes irrelevant or it becomes redundant. Basically, you need not even use that. Yep, that's my take.
Okay, thank you. So I don't know if you recall, friends, when we were initially having a preliminary discussion about decision tree. So while I took the antagonistic role, trying to push the team against decision tree and trying to project it as not a very good model, both of them were very defensive, and I could actually see the that flavor, that shield coming up, and I said, "What is it that is not useful? What do you mean decision tree? Anything about decision tree is not useful? How can you even say that?" I could feel that coming in the response that Bernie has given, and that's how data scientists are very, very productive about especially tree-based, not just decision tree, because that's the foundation for all the ensemble techniques. So you really don't want to mess with decision tree. Yeah, that's how we feel. So coming back to the next question, and I'll take it to Sharath to conclude the session for today. So Sharath, what combination of has it ever happened that when you try to tune the parameters and you try to do everything so perfectly that you end up actually overfitting the model? Is it happening that over tuning can overfit, or how to have that prevent such a scenario? Can you throw some light on that?
Okay, so in decision trees, majority of the people don't have to try too much to get overfitting. That is the drawback of the decision trees. As I mentioned, right, it has the drawback where it is the algorithm which is most prone to become overfit. Now, what we need to talk about is how do you regularize it? How do you control the decision tree not to become overfit? How do we make it more generic in nature? And to do that, again, we try to control the parameters. And we have one specific parameter called CCP parameter, which is basically the complexity parameter, which measures the value for every split. Now, when decision trees are constructed, we are trying to have the, let me share my screen. Yeah, so when we are trying to construct the decision trees, every branch that is getting generated or is getting created is trying to create more homogeneity with respect to your input variables on Y, homogeneity in Y. So we are trying to measure how much homogeneity or how much variance is reduced with respect to your target variable when I work with one specific input factor for splitting the data. So that value is measured here. It's called as complexity parameter. And when you try to grow your tree, we try to control the growth by using these parameters, and we try to do pruning. Pruning is nothing but controlling your growth of the tree. And CCP parameter becomes very, very essential when you talk about post-pruning. And this is more popularly used. Pre-pruning is not such a popular technique, but post-pruning is more appropriate when you're trying to do a model. We try and allow the tree to grow to its full extent and then see which branch is not having any value. And to do that, we use this complexity parameter. So as I mentioned, to control the algorithm not to become overfit, we try and use post-pruning methodology where CCP alpha becomes one of the crucial parameters. There are a number of different parameters, different experiments that we can do with respect to decision tree. And it is all about experimentation. Keep practicing, friends. That's all I can say.
Thank you, Sharad. So I'll just wrap it up the session for today. Decision tree inherently is something that grows wild. And what we are trying to do by hyperparameter tuning is trying to make it grow in an ordered way. So trimming in certain places and cutting the branches in certain ways. So basically, the hyperparameter tuning or over tuning would only result in underfitting if we tune it too much. If you prevent everywhere, you don't let the tree grow at all, you may only have a problem of underfit because of excessive tuning, but you will not really have a problem of overfitting. So that's the sum and substance of the topic for today. Thank you so much, friends. It was nice to have interacted with you. And yeah, we will continue to meet up all days of the week, all weekdays, and keep sharing whatever little knowledge we have for everyone to consume and grow. Thank you so much.
Yeah, please comment, friends, on the comment section so that we also come to know on what's good, what's wrong, what is amazing and what is excellent about this, about these sessions that we are conducting. So please comment. That's a request from my side on the video. Thank you all.